This information was made available by Akpo Oyegwa Refrigeration Company. Like this video, share, comment and subscribe. What is an HVACR system? HVACR stands for heating, ventilation, air conditioning, and refrigeration. It is a system that controls the temperature, humidity, and air quality in a building or vehicle. The system includes various components such as a furnace, air conditioner, ducts, and thermostat, which work together to provide a comfortable environment for the building's occupants. There are several types of HVAC systems, including 1. Forced air systems. These systems use ducts to distribute warm or cool air throughout a building. 2. Boiler systems. These systems use hot water or steam to heat a building. 3. Radiant heating systems. These systems use hot water or electricity to heat a building's floors, walls, or ceilings. 4. Geothermal systems. These systems use the constant temperature of the earth as a heat source or heat sink. 5. Split systems. These systems have an outdoor unit and indoor unit which are connected by refrigerant lines. 6. Packaged systems. These are all-in-one systems that combine heating and cooling functions into one unit, typically located on the roof or outside of a building. 7. Variable refrigerant flow, VRF, systems. These systems use a variable speed compressor to adjust the amount of refrigerant flowing to multiple indoor units. 8. Hybrid systems. These systems combine two or more types of HVAC systems, such as a boiler and heat pump. There are several types of air conditioning systems, including 1. Window unit air conditioners. These are small, self-contained units that are designed to cool a single room or small area. 2. Split system air conditioners. These systems have an outdoor unit and indoor unit that are connected by refrigerant lines. 3. Central air conditioners. These systems are designed to cool a whole building or large area by circulating cooled air through ducts. 4. Portable air conditioners. These are air conditioners on wheels. It can be moved around easily to cool different rooms. 5. Ductless mini split air conditioners. These systems consist of an outdoor unit and one or more indoor units that are connected by a small conduit, which houses the refrigerant and power lines. 6. Hybrid air conditioners. These systems combine two or more types of air conditioning technologies, such as an air source heat pump and an electric resistance heater. 7. VRF air conditioners. These systems use a variable speed compressor to adjust the amount of refrigerant flowing to multiple indoor units. 8. Chiller air conditioners. These systems use a refrigeration cycle to cool large buildings, such as hospitals and office buildings. An air conditioning system works by using a refrigeration cycle to cool and dehumidify the air inside a building. The basic components of an air conditioning system include a compressor, a condenser, an evaporator, and an expansion valve. 1. The compressor compresses a refrigerant, typically a type of fluid such as R22 or R410A, and turns it into a hot, high-pressure gas. 2. The hot gas then flows through the condenser, where it releases its heat to the outside air and condenses into a liquid. 3. The liquid refrigerant then flows through an expansion valve, which lowers its pressure and turns it into a cold, low-pressure liquid. 4. The cold liquid then flows through the evaporator, where it absorbs heat from the air inside the building and turns back into a cold, low-pressure gas. 5. The cold gas then flows back to the compressor, where the cycle starts again. As the air inside the building is cooled, it also goes through a filter to remove dust and other contaminants. Then it is circulated through the ducts by a fan. Meanwhile, the moisture from the cooled air is removed by the evaporator coil and drained away via a condensate drain. The thermostat controls the system, turning it on and off as needed to maintain the desired temperature, and the refrigerant is circulated through the system by the compressor. The temperature range of an air conditioning system is typically between 15 degrees Celsius to 27 degrees Celsius depending on the system and the location. The ideal temperature range for air conditioning is between 22 degrees Celsius to 25 degrees Celsius, which is considered to be the most energy efficient and comfortable range for most people. However, The temperature range can be adjusted according to the user's preference and comfort. The thermostat is the device that controls the temperature in the HVAC system. It can be set to the desired temperature. When the temperature in the room exceeds the set point, the system turns on to cool down the room. There are several types of refrigerants that are commonly used in air conditioning systems, including 1. R22, chlordifluoromethane. This refrigerant was widely used in air conditioning systems for many years, but it has been phased out due to its ozone-depleting properties. 2. R410A, Purin or Suva 410A. This refrigerant is a blend of two other refrigerants, R32 and R125, and is a common replacement for R22. It does not deplete the ozone layer and has a higher cooling capacity than R22. 3. R32, difluoromethane. This refrigerant is a component of R410A and has zero ozone depletion potential, ODP, and a lower global warming potential, GWP, compared to R410A. 4. R290, propane. This is a naturally occurring, low-pressure refrigerant with zero ozone depletion potential and low global warming potential. It is flammable, so it requires specific safety measures and equipment. 5. R744, carbon dioxide. This is a natural refrigerant with zero ozone depletion potential and a low global warming potential. It is used in some commercial and industrial applications, but it has a higher pressure than traditional refrigerants and requires special equipment. 6. R1234YF, HFO1234YF. This is a new refrigerant developed to replace R134A. It is non-flammable and has zero ozone depletion potential and a low global warming potential. It's important to note that new regulations are in place to phase out some refrigerants due to their environmental impact, so it's important to check the regulations and availability in your area before choosing a refrigerant. There are several types of compressors that are commonly used in air conditioning systems, including 1. Reciprocating compressors. These compressors use a piston to compress the refrigerant. They are commonly used in small and medium-sized air conditioning systems, such as residential and light commercial applications. 2. Rotary compressors. These compressors use a rotor to compress the refrigerant. They are commonly used in larger air conditioning systems, such as commercial and industrial applications. 3. Scroll compressors. These compressors use two spiral-shaped elements that move together to compress the refrigerant. They are known for their high efficiency and low noise level, and are commonly used in residential and commercial systems. 4. Screw compressors. These compressors use two intermeshing helical rotors to compress the refrigerant. They are known for their high efficiency and reliability, and are commonly used in industrial and commercial systems. 5. Centrifugal compressors. These compressors use a rotating impeller to compress the refrigerant. They are commonly used in large commercial and industrial systems, such as central air conditioning and refrigeration systems. The type of compressor used in an air conditioning system will depend on the size and capacity of the system, as well as the specific application and requirements. Thanks for watching. Please like this video, share, comment, and subscribe. Akpo Oyegwa Refrigeration Company is your reliable source for HVAC systems.